Hello, today we're going to learn section 10.7 from our intermediate algebra textbook, and it is on inverse functions. I highly suggest taking notes where you see the pencil and trying the problems as we go. Make sure to remember that you can pause and rewind if things move too fast for you, and also fast forward if you're watching it again and just want to get to specific spots. Let's get going. So first, the question is, what is an inverse of a function? An inverse is kind of like a reverse or a flip or a switcheroo. The inverse of a function reverses the order of the inputs and the outputs. Now, what we mean by inputs and outputs is inputs are usually our x's and the outputs are generally our y's. So what we are doing when we're finding an inverse is we are switching the x's and the y's. Okay. The inverse of the function f of x is usually written as f to the negative 1 of x. So this right here is notation, okay? It does not mean we're raising f to the power of negative 1. You are never going to be like solving for f or trying to get f by itself. All this is notation. So for example, if I had something like this, f negative 1 of x equals 2x plus 1, this is just saying the inverse of f of x is 2x plus 1. So it's the flip of my function is 2x plus 1. Okay, so it's just notation. These last two lines are basically saying the same thing. The domain of f is the range of the inverse, and the range of the function is the domain of the inverse. So once again, kind of like the x's and y's switching, the domain and the range also will switch. Now again, the domain are all possible x values and the range is all possible y values. I highly recommend pausing this video and writing this stuff down if you have not already. This slide is filled with information. It's a very important slide, and I say to watch this, but it might do you some good to write it down in case you forget some of these concepts, because some of them are review. So first off, we have the question that says, how do you use a table to find the inverse of a linear function? Linear meaning it's a line. So up here, again, I have so many boxes, it's kind of hard to see, but find the inverse of this function, f of x equals 2x plus 6. We are going to use a table of values in order to do that. So step one is to actually make a table of values. I already have this table of values created, but the way that I created it was plugging in values for x. So for instance, if I started with 0 as my value of x, in order to get 6, I would have to do 2 times 0 plus 6, and that gives me my y value. If I wanted 1 as my x value, I would plug in 1 into the equation, 2 times 1 plus 6, which gives me 8. If I had 2 as my x value, I would need to plug that into my equation, 2 times 2 plus 6, and if I had 3, which I'll use black here, I would need to do 2 times 3 plus 6 in order to get my y value. So all of our y values are found by plugging in our x values. Step 2 here is surprisingly easy. It is basically doing what the definition of an inverse is. An inverse, as a reminder, is where we are switching our x's and our y values. So when I create a table, I am literally going to switch my x's and my y's. So take a look what happens here. In the first column, my original function had 0, 6, now I have 6, 0. In my second line, I had 1, 8, now I have 8, 1. We are literally just switching the x's and the y's. Okay, so step 2 is to make a table of values for the inverse f of negative 1, that's that notation again, by swapping the x's and the y's. Okay. Step 3 is where it requires a little bit a little bit of prior knowledge, and it's to use the table to find the slope and the y-intercept and put it in the equation. So up here you see our equation for a line, y equals mx plus b, where m is our slope and b is our y-intercept. Now for some of us that's going to be a little bit rusty in our mind, so let's review a couple concepts. First off, our slope is rise over run, and rise is how much we go up and down, or the change in our y's, and our run is our side to side, or our change in our x's. So we find that by looking at our table, and we are going to see what is happening to our y's. So it looks here like my y's are going up by 1, and then what is happening to my x's? It looks like my x's are going up by 2. So my slope in this instance would be my rise, or my 1, over my run, which is 2. Second review concept is our y-intercept. As a reminder, the y-intercept is the point where x is 0. Okay, so in the first table, it's clearly labeled as 0, 6. In my second table, it's not as easy to find because I don't have a value where x is 0. So we are going to have to work ourselves backwards a little bit. So if I go backwards 2, that gets me to an x value of 4. If I go backwards 2 again, that gets me to an x value of 2. And then if I go backwards to one more, I'm just following the pattern. That is where I get my x value of 0. So I have to take 3 steps back in order to find my y-intercept. So I'm just going to follow the pattern back on my y column, and that gets me a y-intercept of -3. So to write the final equation here, I get y equals 1/2 x minus 3. That is the equation of the inverse. Now this is, one method to find the equation of the inverse, and this is using a table of values. What I would like for you guys to do is try one on your own. So pause this video, utilize the example that we had just done in the previous slide, and try to find the inverse of this function, and I will show the answer in just a couple minutes. All right, so let's talk through the process that I went through. The first thing I did was created a table of values for the function that we have been given, so 4x minus 2. And I just picked some x values that I wanted, 0, 1, 2, 3, 4. You could pick as many or as few as you wanted, as long as you can figure out the equation. And then I plugged those x values in order to get the y values. Okay, the second step I did was literally switch the x's and the y's. So I created a new table where I flip-flopped my columns. Then the third step is I needed to figure out my slope and my y-intercept, and those are the notes that you see on the side. So I noticed that my y values are going up by 1 and my x values are going up by 1. So when I figured out my slope, I did 1 over 4 because my change in y was 1 and my change in x was 4. The y-intercept was a little bit tougher because it's not clearly labeled. Also, I noticed it's in between -2 and 2. It's halfway in between. So that was pretty easy math to do in my head because I said, well, if 0 is halfway between, then my y-intercept must be halfway between, so it is 1/2. So last, in order to write the equation, I wrote f of -1x, because that is the inverse notation, equals my slope, which is 1/4 x, plus my y-intercept, which is 1/2. What do you notice about the slopes of these inverses? The slope of my original function was 4, and the slope of my inverse is 1/4. They seem to be reciprocals or flips of each other. On this next slide, we're going to start looking at the graphs of inverse functions. So this question is, how do you use a table to graph an inverse function? So our function that we're looking at is f of x is equal to x squared. Now, this is something that we learned about a couple units ago and looked at even last unit, which is quadratics. And quadratics are normally parabolas or U-shaped graphs. Now what's interesting about this problem is that they are saying x has to be greater than or equal to 0. So we're not going to get an entire picture of this parabola because we're limiting our x values to being bigger than or equal to 0. So that's why we created the table that we did. Now as a reminder, again, to create a table of values, you are just plugging in the x value. So if I wanted my x value to be 0, which is a good starting point here, I would be taking 0 and squaring it according to my equation, so I get 0. If my next x value is 1, I am going to take 1 and square it, which is 1. Then if I wanted 2, I would need to do 2 squared to get 4, and for 3, I would be doing 3 squared in order to get 9. So this table of values is easily generated. You could also use a graphing calculator and plug your equation into your y equals button and look at the table that way if you would like. Now to create an inverse function, what do we do again? Oh, we just flip or switch the x and y values. So this table that I'm going to show here is doing just that. My original point was 0, 0. Now my new point is 0, 0. Then I had 1, 1. Well, when you switch it, it's exactly the same. Here's where things get interesting. I used to have 2, 4. Now I have 4, 2. And now I have 9, 3. So again, inverses are where we just switch our x's and our y's. For our last step, we are going to graph the function. So I am just going to spend some time plotting the points. I just quickly plotted the points of my first function, f of x. And again, this is just f of x equals x squared, but x is greater than or equal to 0. So it's half of a parabola. Let's look at the inverse function. The red line is my inverse function. Looks pretty interesting, doesn't it? All that happens is the x's and y's switch, but why do 0, 0 and 1, 1 stay? Well, it's because of the line that our graphs are mirroring themselves across, and we're going to show you that on the next page. So here's the same graph that I just created, and you can see that there's this new dotted line in the middle of them. This dotted line is a line y equals x. Now, this is a weird line to graph all the time, but it's actually 1x plus 0. So it has a y-intercept of 0 and a slope of 1. This is the line we are reflecting our functions across, or our graphs across, when we're finding the inverse. A couple of things I want to mention that show up in your homework that might be beneficial for you to write down. One of the questions in the homework asks about whether something is 1 to 1. As a reminder, 1 to 1 means that every x has one y and every y has one x. So we don't have any repetition. Another great way to sort of think about that is whether something is a function or not. A function is where every x has one y, and we do the vertical line test in order to figure that out. So if I created a vertical line here, let's use green, and I tried to see, hey, does that blue line cross this green line more than once at a time? And no, it does not. And similarly with that red line, it doesn't cross the green line more than once at a time. Again, this is something we've talked about in class before. An example of something that would not be a function would be like a sideways parabola, for example. If I put this green line over there, this is not a function because at any point we have two spots that are on that green line. Okay, so just as a reminder of a couple definitions. Function, it has to pass the vertical line test, and 1 to 1 means every x has exactly one y. Here is a problem we would like for you to try on your own. Graph the inverse of that function. Now you could graph that function using a table of values, or you could use the slope and y-intercept. But remember, an inverse is where we switch the x's and the y's. So take it some time and make a graph on your note sheet and try to graph the actual function and its inverse, and we will review in a minute. All right, so here we have, in the black line is my original function. Now, when I did this, I plotted the y-intercept of 1, and then I went up 1 over 2, up 1 over 2 to graph the rest of the line. However, when I thought about switching that and having to find the inverse, I was like, a table of values could be really beneficial. So then I created this table for my f of x function, which is my black line, and I just wrote down some of the points that I had plotted to make that line. Now you could have plugged these into the equation as well. Note that if you use odd numbers, you will end up getting some decimals. So once I had my table, I just flip-flopped my columns, my x and my y columns, in order to get that red line. Now, if you notice, the red line and the black line meet at that 2, 2, and that's because when you flip 2, 2, it stays 2, 2. So when we're switching our x's and y's, those points are not going to change. Here's the last concept we're going to introduce for today, and it has to do with finding the inverse of a function using algebra, which I'm guessing many of you are going to want to be able to do instead of having to create a table and flipping the x and y columns. Here, using algebra, it's actually very similar. The very first step in order to find the inverse is you are going to switch the input and the output, or basically switch your x's and your y's. So in this function that I have here, f of x equals 2x plus 6. First off, instead of having f of x, let's write that as y. And then all I'm going to do in this first step is I am going to put my x where my y was and my y where my x was. It's that simple. However, we do not want to leave our equation as x equals. That's not our typical way of writing a function. So step 2 is to get y, or f of x, by itself, or solve for that other variable. This is going to be a little bit different than what we've done in the past, but the idea behind this is it's kind of like solving for x, except for we want to get y by itself. So I'm going to imagine my train tracks here, and the very first thing I'm going to do is I'm going to add or subtract any numbers that I could possibly get rid of. So that leaves me with x minus 6 equals 2y. Now again, you cannot do x minus 6 because they are not like terms. All right, we're getting closer. We again want to get y by itself. So I have to get rid of that 2. So I'm going to divide both sides by 2. That's going to cancel out my 2's over here, which leaves me with y equals x minus 6 divided by 2. Now there's multiple ways you could write that. If you wanted to write it as two separate fractions, you absolutely could. So we've talked about that when we were simplifying with the quadratic formula. I could write x divided by 2, and then I could also write negative 6 divided by 2, or minus 6 divided by 2 equals y. Lastly, I could simplify this a little bit further to get a nice final answer. This is really like 1/2 x, and then 6 divided by 2 is 3. Okay, so that's more of a slope intercept, or y equals mx plus b form, but you could leave it, I believe, according to Pearson, I think you could leave it in this above option as well. Finally, instead of writing y, I want to use inverse notation, so I want to have f to the negative 1 of x. Now again, that negative 1 power doesn't mean I'm raising it to the negative first power. It's just notation that means inverse. So there's my inverse function. Last one, let's have you guys try this one on your own. Pause the tape and we'll come back and check your answers. All right, and here we are. The very first step that I did was I switched my x's and my I wrote it as y equals x minus 7 instead of f of x. Then I switched my x's and my y's in order to start the process. Lastly, I had to add 7 to both sides in order to get y by itself, and then I rewrote it using inverse notation, or that f to the negative 1 power. So my answer is the inverse of f is x plus 7. Okay, I hope this helps you guys. Go ahead and get started on your 10-7A homework, and let me know if you have any questions.